Hello all. So in this lecture, we'll see about conditional iteration, and in conditional iteration, we'll see while loop. So we have already seen for loop. So in for loop, the number of times is specified by the programmer. But in most of the cases, this number of iterations in the loop is unpredictable. So loops, what they do is when some condition changes, the iteration or the loop has to stop execution and it has to execute some other thing. So in those cases, we have to go for this for while loop instead of for loop. So for loop iterates a number of times specified by the number of times is specified by the program. But in while loop, it is specified by the condition. When we execute something and if some condition change occurs, then we have to exit that loop. So that condition, that specific value is known as sentinel. That sentinel will terminate the loop, terminate the input, and it will stop the execution and it gives some other statement. So this is known as conditional iteration. So we'll see the structure and behavior of while loop. So conditional iteration, it is a condition that will be tested within the loop. Conditional iteration will be tested inside the loop. So to determine whether the loop should continue execute will be done inside the loop. So if the continuation condition is false, the loop ends. If the continuation condition is true, the statements within the loop are executed. We call this as continuation condition. So this is the general structure of a while loop. While, condition, colon, sequence of statements. So if you see this statement, this loop, it is more or less similar to this if statement we have already seen. One way if statement we have seen. So only difference is instead of if we are using while. The difference is in that if loop, if the condition is false, then it executes. It exits in the and if the condition is true, if condition is true, it will execute the set of sequence of statements only once. But in this case, while condition, whenever that condition is true, it will execute the statements and again it will check whether the condition is true or false. So it goes on repeating. So this is a looping. It goes on repeating. Whenever the condition is true, the set of statements is executed iteratively. Okay, in the case of if loop, it will be executed only once. So this is the figure, you see the figure, this is a figure. If we will check for the condition, if it is false, it will execute the statements after the while loop. If the condition is true, then it will execute the statements inside the loop. After that, again, it will check the condition. And if it is true, again, it will execute the statement and again, it will check the condition like that. It will go on repeating. So this is the steps. These are the steps that is involved in this while loop. First, evaluate the condition yielding 0. Yes, 0 or 1, 0 means false and 2, 1 means 1. If the condition is false, 0, exit the while statement and continue execution at the next statement. That is, this happens here. Then if the condition is true or 1, execute each of the statements in the body and then go back to step 1. That is, again it will go check the condition. So we'll see one example. So this is an example just to input a number. It will continuously enter some numbers. Whenever a number enters, it will be added. Okay, we will get the sum of n numbers. So here sum is initialized to 0. Then we are asking for input and a number just enter ticket. So whenever we press a number and press enter key, again that is to be repeated. After that, when we press double enter, it should exit. So that's why, well, while data not equal to empty space. That is, when we press enter key, until and unless we press enter key, this loop has to be repeated. So these all statements will come under this while loop because it is the same intent. Like in while if also we have seen. So these are all the intended. These are all intended at the same space. So number, we have to enter number, some number, data value will be entered and it will be converted to float value. Then it will be added to the sum. Sum plus equal to number means sum equal to sum plus number. Then again it will be a prompting for this value, enter a number or just enter to quit. So this will go on repeating until we press enter key. So we'll execute this and see this. So enter a number. So if you want, you can enter a number like this. Again, it's asking for number. I'm again entering a number. Again, I'm entering some number. You can enter as many as numbers you want. Again, it will go on repeating like this. And if you want to stop, you have to simply press enter key. So you will get the sum like this. Okay. So this loop will go on repeating until this is not equal to. So not equal to, when you press enter, it will go on repeating like this. So it will enter the values like this. It will keep on asking this question. And when we enter that value, it will be converted to float and it will be assigned to number value. Then it will be stored in sum. Then we will print this sum. So this is one example. Then next is count control with while loop. So, like for loop also, we can count the count. We have already seen in for loop, we have counted the number of iterations in a loop. So, we will see some example first. So, leave this code, you will see this code. So, how to do this count control? So, we are assigning 0 to sum. Then for count, this is a for loop. We have already seen this for loop. For count in range 1 to 10,000, you can simply count and then you have to print this up. So you know how to execute this for loop. We have already seen the previous lecture. So will be counting and that count will be added to the sum. Okay. So this is the how you will execute this statement and you can see the result is this much. So it will be counting that loop 10,000 times. You will be adding all those 10,000 numbers. And now let me take another statement. I am copying this theme. I am pasting it here. So this is the same thing using while loop. So here sum equal to 0 and we have initialized a count variable to 1. But in the case of for loop, it will be automatically initialized to 1. But in the case of while loop, we have to initialize that count control variable here 1. Then while count less than or equal to 10,000, up to less than or equal to means we can count up to 10,000. 10,000 also will be included. Then we have to sum this count plus equal sum plus equal to count means sum equal to sum plus count. Then after that, in the case of for loop, automatically that count variable will be incremented. Here we have to increment that count variable, count equal to count plus 1. Then after that, it will go on repeating like this. And finally, that sum value will be printed. You'll get the same result. You'll get the same result here. So this is the thing what you have to do. But so we'll see what's the difference. Here you compare these two loops. So this is a while loop and this is a for loop. So if you see, this is much more complex. So if while loop is much more complex. When you do this count control, this while loop is much more complex. We have to have this count variable and that count variable should be initialized. In the case we need not initialize. In the case of for loop, we need not initialize this count. It will be automatically initialized to 1. And here we have to increment that count value. Here it will be automatically incremented. That count value will be automatically incremented. So while loop will be much more complex in the case of um, counting some values. So there is a possibility of some errors can occur in the case of if you do this while loop. But in certain cases, you have to use this while loop itself to count the thing. Okay, so logical errors can occur in this while loop. So you have to be careful when we use this while loop. Okay. Then countdown is also possible. We have already seen for loop this countdown. For a countdown operation, we have to initialize this 10. This is a lower, this is the upper thing, or this is upper and this is lower. We have to count from 10 to 0, and -1 is the decrement counter. Then we can simply print this count value. It will count from 10 to 1. 10, 9, 8, it will go on like that. So same loop, if we are writing in while loop, it should be like this. We have to initialize this count to 10, then count greater than or equal to 1. What you have to do? Print count. Then inside that while loop, we have to use a count variable such that it decrements. Count equal to count -1. In this for loop, we can initialize it here itself. We can do it in the header itself. But here, inside the loop, we have to use that counter. Okay, so this is countdown loop. We'll see some examples. So we'll see some example programs for this while loop. Okay, this we have already seen. Okay, we have already seen this sum statement. Oh, this is another way of writing this loop while true. So this is using while true statement, and I have included a new statement in this. This is the break statement. Break statement. So we will see how to use this loop. So, most of the cases we may sometimes write the loop instead of this condition, we will write this true, while true. So, this is known as while true loop. So, this loop goes on executing until this stage, this becomes something inside the loop happens as that it breaks out. So, this is a kind of infinite loop. So, if we want to stop this loop, some condition should be written inside, or something should be written inside the loop such that it breaks, it stops its execution. So we will see what we have written. So this loop, so these are the statement inside the while loop. What it does is it will ask, it will prompt the user to enter a number or just enter Euclid. Then if it is enter key, if data equal to this enter key, what it has to do, we are including a break statement. So what this break statement does is it stops its execution here. It stops its execution here. It will break out of the loop and it will print the sum here. If it is not enter key, then it will continue its execution. Like in the previous example, we have already seen that data will be converted to float and it will be assigned to number, then sum will be found out. Again, it will go here, it is true again, then data will, this will be prompted. Then it will again check whether it is an enter key. If it is an enter key, it will stop execution. So we'll run this program. So enter a number. So we are simply entering some number. If you want to stop, you just press the enter key. So that if loop will break out of it and the sum will be printed. Okay. Then we will see another example. So this is a simple while loop. We are simply printing this simple example while I less than equal to less than 6, print I. This is a kind of count control loop. So we'll see what is the output. So we can get the output as 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then since it is I equal to 1, then I less than or equal to 6, 1 less than 6, it is true, print 1. First it will be printed, then it will be incremented, I becomes 2. Then again it will check condition 2 less than 6, it is true. Then print I, that is 2 will be printed. Again I will be incremented, I equal to I plus 1. So I becomes 3. Then 3 less than 6, then print 3. Like that it will go on repeating. Now I will use this one. Okay. So this is break statement. So this is another example. So I equal to 1. Then I less than 6. We are printing the statement. But whenever I becomes 3, it will break out of the loop. Okay. Whenever I becomes 3, it will break out of the loop. So otherwise, if I not equal to 3, then I will be incremented. Okay, we will see this program. We will run this program. Sorry. I equal to, sorry, this should not here. Okay. So 1, 2, 3. So only 1, 2, 3 will be printed because when the if condition, if when I becomes 3, it will break out of that loop. So this is an example to show how to use this break statement. So whenever I becomes 3, it will break and it will execute. There's no other statement that is to be printed. So it will stop execution. So this is a case of break statement. Then we will see another statement, that is continuous statement. So what is the use of this continuous statement? So here I equal to 0, then I less than or equal to 6, so 0 less than 6. Then here I plus equal to 1. So what happens is, uh, here we will run this program and see this. So here 1, 2, 4, 5, 6 will be executed. 3 won't be executed here. So here 3 won't be executed. So what we'll see why this happens. So what happens here is we are initializing I to 0. Then 0 is less than 6. It is true. So what it does is I is incremented. I equal to I plus 1. So I becomes 1. It will check if I equal to 3, 1 equal to 3. It is not, it is false. So it won't execute this continuous statement. Instead, it will print 1. Then again, it will come here. 1 less than 6, it is true. Then I is incremented to 2. 2 equal to 3, it is false. So again, print 2 will happen. Next, 3. Then now it is 2. 2 less than 6, it is true. Then I is incremented to 3. Then it will check if I equal to 3. 3 equal to 3, it is true. So what happens? It executes this continuous statement. So when it executes this continuous statement, it will go to this while here. It won't execute this print. Instead, since it is continue, it has to continue this loop. So we have it is to continue this while loop. So it will go here and again it will check 3 less than 6. Then I becomes 4. 4 equal to 3, it is false. So it will be printed. So that is why here when 3 occurs, that print statement won't work. It will go back to this while loop. That is why 3 is not printed here. 1, 2, 4, 5, 6 will be printed. We will be skipping that 3. So that is the use of this continuous statement. Okay. Now we will see random. Another example, random. So this is a program. So we have to predict a number. So this program, what it does is the computer will randomly guess a number between some range. So we can give some range 1 to 100, and the computer will randomly generate a number. Maybe some 25 or 27 will be generated. We don't know that number, and the computer asks us to predict that number. So we have to input some number. So if the computer has generated 25, and if we say we have guessed it as 50, then computer will say it is too large. Then what we have to do, we have to reduce it to some other number, 30. Then computer might say it is again large. Then we will say 10. So computer will say it is small. So we understand that it is between 10 and 30. So we will say some 20. The computer will say again it is small. So we know that it is between 20 and 30. Then we will say 24. It will say it is small. Like that, it will go on, keep on running until you correctly guess that program. So that is a program. And run this program and show it. So enter the smaller number. We can specify the range. So this is a range, and we are specifying 1 to 100. So we have computer has already predicted some number, and I'll be guessing this number 56. It is too large, so I'll make it 25. Too small, so it is between 25 and 56. Now I will say it is 40. Ah, it is correct. So we have got it in 3 tries. So 40 was the random number that is generated by the computer, and I have automatically guessed that. So we will see that first we are importing this random. This module is needed because we are using a random function. Now, smaller, what we have to do, we have to enter a smaller number. We are inputting that. We have already seen. We are converting it to integer type, and it will be stored in, assigned to smaller. Then we are asked to enter a larger number, and it will be stored in larger. Then this my number is a number generated by the computer. So this is a random function. Random function. So random function, what it does is it will predict a number between the smaller and larger. If you are giving 1 to 100, it will predict some number. The system will automatically generate some random number between these two numbers. Okay, that is stored, that is assigned in my number. Now we are initializing a count variable to 0, and this loop will be executed while true. This is a while true loop example. Then count is incremented to 1. Then user will be prompted to input enter your guess. Okay, that will be assigned to user number. Now we are checking whether our entered number is less than my number, that is generated by the computer. If it is less than, then we will print too small. Else if user number is greater than my number, the predicted number is greater than the random number generated by the computer, then it will print too large. Else we will print congratulations. So this will go on, and it will break out of this loop. So this will go on repeating until you guess the number correctly. We will once run this program once more. I am entering some other number, let it be 28 and 56. So you have to predict a number between 28 and 56. So I'll input as 40. It is too small. So the number is between 28 and 40. Now I say 30. 30 is also small. So it is between 28 and 30. I think it is 29 itself, maybe. So it is 28 itself. Oh, sorry. I have wrongly guessed it. So since it is entire 40 is too small, let me execute. I have incorrectly. Okay, sorry. So let me be 1 and 100. So enter your guess. My guess is 45. It is too small. So it is between 45 and 100. So let it be 75. So it is too small. It is between 75 and 100. So let it be 85. It is also small. So it is between 85 to 100. So I put it as 90. It is too large. So it means it is between 85 and 90. So let it be 87. Yeah, it is correct. So I have got it in 5 tries. So this is the program that is written here. So this is an example for while and if statements. So while if statement, else if you including this break statement, it will break this out whenever you guess it correctly. And otherwise it will go on continuing. So this is another example. In while loop, there is we can include an else statement also, like in for also we have included. So this is not mandatory, this is an optional thing, just for your knowledge. So in while also we can include this else. So when it finishes its execution, when this finishes its execution, it will continue this to the statement and I is no longer less than 6. It will simply print like this. The same program 1, 2, 3, 4, 5. After that, I is no longer less than 6. So it will stop its execution. Okay. So this else statement can also be included in a while loop. Then we will see another program to find to check whether a year is leap year or not. So you have to understand what is a leap year. So any year that is evenly divisible by 4 is a leap year. All these are leap years, but a year that is evenly divisible by 100, which is divisible by 4 and which is divisible by 100, may not be a leap year. It may be a leap year only if it is also divisible by 400. So all these conditions should be checked. It is not always divisible by 4. In some cases, if it is divisible by 100, then we have to check whether it is divisible by 400. For this reason, the following years are not leap years. Even though this is divisible by 4 and it is divisible by 100, it is not divisible by 400. So these are not actually leap years, even though it is divisible by 4. So you have to check all these conditions. So first condition we have to check is whether it is divisible by 4. Then after that you have to check whether it is divisible by 100. And if it is divisible by 100, then it should not be divisible by 400. If it is also divisible by 400, then it is a leap year. Okay. So that is, so the user will be asked to enter a year. So a year will be stored, will be assigned to that year. If it enter some year value, then it will first check whether it is divisible by 4. That is where it is equal to 0. Then if it is equal to 0, if it is not equal to 0, then we can simply print that it is not a leap year. Okay, we can simply print that it is not, else will execute, this else will execute. So this if and this else are intended at the same. So if this is not not equal to 0, then automatically it's not a leap year. So print year is not a leap year. Then otherwise, if year, if it is divisible by 4, then again it has to check whether it is divisible by 100. If it is divisible by, if it is not divisible by 100, then you can simply print it is a leap year. If it is divisible by 100, you can simply print. If it is not divisible by 100, you can simply print it is divisible, it is a leap year. If it is divisible by 100, again you have to check whether it is divisible by 400. So if it is divisible by 400, then it is a leap year. Otherwise, again, this is not a leap year. So you have to see all this if else statement. So this if and this else should be intended at the same position. This if and this else will be at the same position. This if and this else will be at the same intention. So in this way, you have to check for a leap year. So you can run this program. You can simply enter some value. So I am entering 2020. So it is a leap year. Okay. You can simply check this with some other thing. I'll input as 2019. It is not a leap year. Okay. Then another program. So it is to find the largest of three numbers. We are inputting three numbers. So three numbers will be inputted. All those will be converted to float. Then we are checking if number 1 is greater than or equal to number 2, and we are using the AND condition we have already seen, and number 1 greater than or equal to number 3. So this means number 1 is greater than number 2 and number 3. So we will assign this number to largest value. Else, what you have to do, number 2 we are checking with, number 2 is checked with number 1 and number 3. If it is true, then num2 will be largest. Otherwise, number 3 will be largest. Then we will be simply printing this largest value. So this is a program. You can enter any float value. We have entered three values and largest number is 34.5. Okay. Then another program is to check whether a number is prime number or not. So you are the programmer will be asked to input a number, and number will be an integer number. Then if number greater than 1, if it is greater than 1, only we have to check all these things. If it is -1 or less 0 or any other number, then if it is, even if it is 1, number is not a prime number. You have to print it is not a prime number. So prime number factors occur from 2 only. So we can include, so in order to check that, we are including this condition if number greater than 1. If the number is greater than 1, then this for loop will execute. For I in range 2 to number, from 2 to number only we have to check. So we have to check whether any number is divisible under that number from 2 to till that number. So if number mod I, so if it is divisible by that number, then the remainder will be 0. Then we have to print that it is not a prime number and break. Otherwise, this loop will be continue its execution until it reaches this number -1. Until it reaches this number -1. That is, if you are inputting 10, it will execute till 2 to 9. So it will check for 2 whether 2 is divisible by 9. 10 is divisible by 2. Then we'll check for 11. If we are inputting this number as 11, so what it does is 2 to 11. So 2 to 10 will be executed. So number 11 mod 2 will be checked. It is not, it is false. So again, it will be incremented. It will become 3. Then number 11 mod 3 will be checked. Like that, it will go on repeating until 11 mod 10. So finally, if all the conditions are false, then it will print that the number is a prime number. Okay, in this way you can execute. So you can enter some number. If I am entering this number, 11 is a prime number. So this loop will execute from 2 to that number -1, number -1. So it has to check. You can even reduce this up to, you need to check only up to that number by 2, because no other, if you are taking 50, no other number will be divisible by more than 25. So you can stop at 25. You can repeat up to 49 also. Okay. This is another example to find the factorial of a number. So a number should be input and a number. We are initializing a factorial to 1. If number less than 0, factorial does not exist for negative numbers. Else if number equal to 0, then the factorial of 0 is 1. If factorial of 0 is 1, you have to print. Else, if it is not negative number and if it is not 0, if it is some positive number that is entered, then we have to start from 1 to that number plus 1, because we have to print up to, if it is 5 factorial, we have to repeat this loop from 1 to 5. We have to 1 into 2 into 3 into 4 into 5 we have to do. That is why we have made it number plus 1. Then factorial equal to factorial into I. So each time I becomes, first time I is 1, factorial is 1, so 1 into 1 is 1, then again I becomes 2, then factorial is now 1, 1 into 2 is 2, then I becomes 3, then 2 into 3 becomes 6, like that it goes on repeating. Finally, the factorial will be printed. We'll run this program. So you can enter any factorial. So if you enter 5, the factorial will be 120. So in this way you can repeat this program. Then we will see Fibonacci series. Fibonacci series. So Fibonacci series, I hope you know this Fibonacci sequence. So it is an integer sequence of 0, 1, 1, 1, 2, 5, 8. That is, the first is 0, then next is 1. The next digit is found out from 0 plus 1. It is 1. Then this 2 is got from the previous two digits. 1 plus 1 it is 2. Then 1 plus 2 it is 3. 2 plus 3 it is 5. 5, 3 plus 5 it is 8. Then 5 plus 8, 13. Like that it goes on repeating. So this is known as Fibonacci series. So here we have to enter number of terms. So if we want 10 Fibonacci numbers, then we have to enter 10. So you will be storing it in n terms. Then we are initializing these two n1 and n2 to 0 and 1. So n1 is 0 and n2 is 1. Then we are initializing a count variable 0. If number of terms less than or equal to 0, so we have to stop execution because only positive numbers we can enter. Else if number of terms equal to 1 means we have to simply print n1. That is, number of terms is 1 means only 0 need to be printed. So we will simply print 1. Otherwise, if it is greater than 1, then what we have to do is print Fibonacci sequences. Then we will repeat this while loop count. So initial value of count is 0, 0 less than number of terms. Then we have to print n1. Anyway, we have to print the 0, 0 first. Then n term is n1 plus n2. N1 plus n2 is 0 plus 1, it is 1. Then what you have to do, we have to repeat this. Then we assign this n2 to n1 and nth term to n2. That is what we are doing here. So we have to change this 0 to, when we generate 0 and 1, what you have to do is, then we have to add 0 plus 1 and we will get 1. Okay. After that, we have to add 1 plus 1. So that is why we are doing this thing. So, and we are getting the nth term as n1 plus n2. Then we have to, what we have to do is n2 is assigned to n1 and this nth term is assigned to n2. Then again count will be incremented. We will check whether it is less than number of terms. We will print this n1. This goes on repeating like this. So if you're entering 25 terms, so this is the 21st 25 terms 0, 1, 1, 2, 3, 5. It will go on like this. Okay. This is Fibonacci series. So these are some of the examples. So I have a few exercises. These are simple exercises. So here, first example is exercise is a write a program that accepts the lengths of three sides of a triangle as input. Then what you have to do is this is triangle's three sides. So it should indicate whether it is whether the triangle is an equilateral triangle or right angle triangle. So you know what is equilateral triangle. What you have to do is you have to check all the three sides. If it is all the three sides are equal, then it is an equilateral triangle. Otherwise, you have to check whether it is a right triangle. So what you have to do, you know Pythagoras theorem, that hypotenuse squared equal to that base squared plus alternate squared. So you have to check the largest, you have to take which is the largest side, and whether you have to check whether squared is equal to the sum of the other two squares. Okay, then it is right triangle. Then second program, modifying the guessing game program. We have already seen the lecture discussed so that the user thinks of a number that the computer must guess. The computer must make no more than that the minimum number of guesses. What you have to do is you have to reverse that action. In the program example we have seen is the computer will guess a number, will predict a number, will guess a number, and we try to predict that number. So we have to reverse it. We will guess some number, and we will ask the computer to guess it. So computer will say 25. We will say we have to say it is too small or too large. Like that, we have to reverse, and finally the computer will should successfully predict that number. Okay. Then exercise third question is GCD of a number. You have to find the greatest common divisor of a number. There's an Euclidean algorithm. Don't get confused by those whole sentences, big sentences. Euclidean algorithm is there to find the greatest common divisor of two positive integers. I will give that algorithm. This is algorithm. What you have to do is compute the remainder by of dividing the larger number by the small number. Here we will be inputting two numbers, one small number and one large number. Maybe it will be 25 and 36, like that we will be inputting. So what you have to do is compute the remainder of dividing the larger number by the small number. So 36 more 25 should be found out. The remainder will be 11. Now what you have to do is replace the larger number with the smaller number and the smaller number with the remainder. Then we have to repeat this process until the smaller number is 0. We have to repeat this until the smaller number is 0. The larger number at this point is the GCD of A. Whenever that smaller number is 0, then the larger number at this point of GCD of A and B will be uh, the GCD. So write a program that lets the user enter two integers and then prints each the process of using the Euclidean. So this is a Euclidean algorithm. It is a simple algorithm. The logic is given here. You can write this program. Then another exercise, write a program that receives a series of numbers from the user and allows the user to press enter key. This is what we have seen in the same program. What we have already seen the sum of numbers. Now we have to print the average also. Okay. So we have to keep the count of the number of numbers n, then only we can find the average. So we have to find sum and average of the n numbers. Then to check, we have already seen this leap year or not. Leap year or not, we have to use this logic here has to be applied here. The same thing, the same program we have seen. Then we have already seen this Python prime number program. But here we have to print prime numbers between an interval. So we have to enter some interval like 2 to 25. Then we have to print all the prime numbers between 2 and 25. So you can simply do this program. Then another thing we have already seen the example, the factorial. To find the factorial number, you try this program. Then write a program to deploy the Fibonacci series sequence of subtracting. We have already seen this program on the example. So this is the Fibonacci series. The first two terms are 0 and 1. All other terms are obtained by adding the preceding two terms. This means to say the end term. We have already seen this program. Hope you are. Then another program is there. It is a program to check if the number is an Armstrong number or not. So what is an Armstrong number? So if it is a 4-digit number, or if it is an n-digit number, A, B, C, D like this, if it is 1, 2, 3, 4, 5, 6 like some other, or it is 2, 3, 4, 5, 2, 2, 2, 5, some number it's there. What you have to do is, if it is a 4-digit number, then the Armstrong, if it is an Armstrong number, if this is true, that is a raised to n plus b raised to n, where n is the number of digits. For example, 153 is an Armstrong number since 1 cube plus 5 cube plus 3 cube is equal to 153. That is what you have to check is if it is a 3-digit number, then we have to check 1 cube plus 4 cube plus 3 cube. If it is a 4-digit number, then you have to check 1 raised to 4 plus 5 raised to 4 plus 3 raised to 4, 4 plus 7 raised to 4, like that some other number if you are giving. So you have to check only for 3-digit number. Okay, you have to check whether it is a Armstrong number. 3-digit number is an Armstrong number. You have to only find out the cube of that number. 1 cube plus 5 cube, or 2 cube plus 5 cube plus 7 cube. Like if you are entering 257 as input, you have to check whether 2 cube plus 5 cube plus 7 cube is equal to 257. So this is the exercise. So this is a reference book. Thank you.